everyone, welcome back. Today we're going through CHOP Part 3 and Chapter 3.7, Technology Systems. Introduction. Technology systems play a vital role in today's architectural practices. Digital drawings, documents, and communication enable the firm to move fast. However, to have these systems function to meet the needs of users and with minimal downtime requires specialized expertise. This chapter will discuss a framework for developing a firm's technology systems, the digital-first approach to technology system development, and the key systems in a firm that can be enhanced with the application of technological solutions. Role of technology systems. A technology system can be viewed as a business process accelerator. For example, existing processes such as schematic design, design development, or contract document production can be accelerated using CAD, computer-aided design and drafting, or building information modeling, BIM, technologies to enhance the speed and accuracy of practice processes. This concept applies to any system in the business, including project management, practice management, and financial management. The adoption of a business process accelerator requires identifying the business needs, then specifying the requirements and scope of work in order for a competent staff member or service provider to design, build, and implement the system. Software development lifecycle. A methodology known as the Software Development Lifecycle, SDLC, used in systems engineering and software development can be applied to build technology systems within the firm, and is not limited to new software and/or hardware. The 6 phases of the lifecycle are: plan, identify that current practice/business processes are unsatisfactory and changes are required. Decide that a business process needs to change and the support of a technological solution is required. The goals of new or modified processes are established in this phase. This can be as informal as determining that a spreadsheet is not providing the functionality needed to manage finances, and that a more comprehensive solution will support business decision-making. Information gathering. This phase gathers information, identifying problems through reviewing current project and operational processes, imagining possibilities for innovation, and determining change needed to meet new business requirements and build core competencies towards a more competitive advantage. Analysis. Analyze the problems through breaking down issues to find root causes and interpret the analysis into a list of technology system requirements. Design. Working with the requirements, this phase involves developing a design to meet those requirements and choosing products, services, and/or vendors to enable them. Build/deploy. Build the system components, test the system, and deploy and configure the technology system throughout the organization. Maintain. Once a system is implemented, it enters the operating phase when ongoing maintenance activities are required. As technology systems tend to generate data and be used by many people, there are many activities related to user access and data life cycles. Plan. Digital first. Digital transformation for transitioning existing systems is a newer concept in information technology systems. It is based on reimagining processes from first principles, as though they have been invented only in the era of modern technologies. Building information modeling, BIM, is an example of a technology considered not financially feasible prior to the availability of powerful and economical computing technology. This concept may not yet apply to all systems in business in general or in architectural practices, such as accounting or payroll, because those processes are regulated by long-standing national and international standards and norms. In this scenario, core business requirements must still be identified. However, a digital-first approach may result in a significantly different outcome than adapting a traditional process to employ contemporary technologies. digital-first approach goes together with rethinking the traditional business model of architectural practice and developing new approaches to practice that seize opportunities. Information gathering. Information gathering is a process of collecting information about existing processes, proposed innovations, and the requirements for improvement. Involving those responsible for executing project or operational processes is critical to the success of requirements gathering. Purchasing the most feature-rich software and expecting it to accelerate performance may be attractive and perceived as an immediate solution to a problem. However, a firm's business processes may need only a fraction of those features, and money and effort would be wasted. Conversely, if the firm needs specific features and the software purchased cannot meet those requirements, then more work would be required to find the right software or customize the purchased software, resulting in wasted effort and money. Investing the time to gather the requirements for current and reimagined business processes leading to technology system solutions can save the firm time, effort, and money. Information gathering may include using tools such as brainstorming, mind mapping, or gap analysis. Analysis of requirements involves identifying and categorizing the root causes of problems on the pathway to innovation and developing and prioritizing solutions. Identification and categorization. Developing a list of technology system requirements first involves a deep dive into a problem or innovative challenges through breaking down the problem or need into a hierarchical list of root causes. The ultimate result of this stage of analysis is a hierarchy list of causes that the technology system is to address. After choosing the most critical and strategic issues to be addressed, the next stage is developing a list of requirements to address the needs that can then be prioritized through categorization. There are many ways of categorizing a requirement for technology systems. A simplified method categorizes requirements into must-haves and nice-to-haves lists. Must-have. These requirements are part of the core business functions, either to meet client requirements, address operational deficiencies, or protect the business's critical systems. For example, individual workstation file backup systems are prone to both hardware and operational failure, relying on each employee to ensure that the backup was successful. A centralized backup and verification system are required to protect against loss of data. Nice to have. These requirements are important to the business, but it would not be detrimental if the feature was unavailable. For example, if the schedule and resource management software had the ability to export data to the accounting system, it would streamline operations, but the business could still function without this feature. Types of requirements. Requirements listed as must-have and nice-to-have can be further categorized into functional and technical. Functional requirements relate to what a software allows a user or the firm to do, while technical requirements refers to the system requirements of the computer or operational needs of the business. Functional requirements are user-driven and relate to a system's operational functions and operational features. For example, building information modeling must support BIM software must support client-required deliverables, such as models, data extracts, or any combination thereof. It also must support all related processes and functions of construction management. In a time-based design contract, clients require up-to-date and timely reports of progress and hours expended on their project. Technical requirements are typically system-driven. The power and capacity of the hardware and software must address operational needs for the speed of operations, security, or system integration. As an example, basic system requirements for a design or production workstation for building information modeling software include CPU core count, threading and speed, RAM capacity, graphic processor speed, memory and efficiency in creation and processing vector graphics, storage type, mechanical disk, solid state, and/or cloud-based capacity, integration with office network systems, including network speed, to enable seamless data exchange with external entities and security. Additional considerations: legal/professional responsibilities. Each province and territory has statutes of limitations, legislation that stipulates the time period within which a claim may be made against an architect. Professional liability insurers require that project and business files that may relate to a claim be retained for at least the period of the statute of limitations. Architects are advised that not all electronic media provide reliable storage of data over extended periods of time. Decay of the data may occur. Retrieving stored data and testing for reliability of reading and transfer are essential to the management of practice risk. Canada Revenue Agency, CRA, stipulates that an audit of a tax return may be conducted up to 7 years after submission of the return. Architects must retain financial and tax records until the period of auditing has lapsed. Training. Training is an important consideration when rolling out technology systems. For example, firms may need to spend more resources on training because staff are focused on thinking in terms of existing technologies. For example, the shift from traditional computer-assisted drawing to building information modeling requires not only an upgrading of technical skills, but also changes in design approach, operational workflow, and design project lifecycle. A rethinking of operational models is required. Refer to the Canadian Practice Manual for BIM for discussion of technology systems required for planning and implementing BIM. Designing a system to meet the office's needs requires consideration of multiple factors. It is often easier to buy products as needed to solve immediate problems. However, there are risks and consequences to implementing new technology systems, particularly when integrating with existing systems. For example, a business may purchase accounting software and upon implementation find that it cannot integrate with the payroll system. Technology systems can be complex, but there are several factors that can aid decision making. Total cost of ownership, TCO. The total cost of ownership is a method to compare different options when analyzing technology systems. The total cost of ownership includes the financial outlay, as well as the time and effort spent researching, purchasing, and maintaining the system. As maintenance is ongoing and theoretically indefinite, it is often acceptable to choose a fixed period of time, such as 3 to 5 years, to enable an apple-to-apple comparison of options. Total cost of ownership includes capital cost, the initial investment required to procure the hardware and/or software; operational cost, the human resources costs associated with system operation and maintenance, deploying software, managing network solutions, maintaining a data backup solution; training time and cost, including the lost productivity while staff are away from the office participating in training activities. It is now commonplace that software is only available on a subscription basis rather than as a perpetual license, requiring an annual operating expenditure for the subscription. By analyzing the cost of a given system with the TCO method, an objective apples-to-apples comparison can be conducted. For example, purchasing accounting software may appear to be more economical because of the one-time cost, but the added time and expense required to maintain the system may result in higher than expected ongoing operating costs. Using a software as a service provider, such as a payroll management service, may reduce actual operating expenses and reduce practice risk by providing data backup as part of the service. Since the SaaS provides backup services for all of its customers, it can leverage economies of scale to make backup costs per client negligible, whereas a firm would otherwise have to pay for the entire cost of this infrastructure. Technology systems may be designed for insourced resources, those employed by the organization, or for outsourced software-as-a-service providers. Many firms will employ a combination of both approaches to achieve a balance of efficiency and effectiveness. Insourced. The insourced approach requires the hiring of an IT professional to plan, procure, implement, and maintain technology systems. The advantages of the insourced approach for the firm are greater control over operations, reduced response times in the event of urgent need, and the ability to create a custom solution for their unique challenges. The core competency of most architecture firms includes having architects and architectural technologists completely conversant in the application technology for the design process. It is now a commercial and competitive requirement that firms have an in-house BIM manager. In-house staff also can enhance a firm's core competence if rapid response to client need is key to competitive advantage. Disadvantages include the time and expense of human resources committed to build technology systems, and the constant prioritizing and reprioritizing of operations as IT staff are pulled from one urgent project to another. Having in-house IT staff can result in a perception that resources are always available to handle any need, leading to ad hoc or reactive management. Outsourced. Software as a service, SaaS. In recent years, it has become possible and economical to run a business using online SaaS providers. There is a rich ecosystem that covers the basic functions of a business, such as accounting, financial management, human resource management, payroll management, project management, document management, collaborative communications, etc. SaaS providers typically focus on one area of technology systems and become specialists and experts. They also manage system and application maintenance, and in some cases offer free email and online support, with the option of premium phone support. The advantage of SaaS is that it allows the firm to focus on its core business, architecture, as most SaaS providers charge on a per-user, per-period basis. Costs increase as the company grows. This can be a cost disadvantage for large corporations, but could be advantageous for small and medium-sized enterprises, SME. Managed services. A firm may contract with a company that provides managed services. In this scenario, the firm would hire a company to manage their technology systems. The managed services company would be responsible for designing and procuring hardware and software, implementing and maintaining the technology systems, and providing staff training. This approach requires strong vendor management skills to be successful. By applying the total cost of ownership (TCO) method to compare insourced and outsourced approaches, the firm can objectively analyze options in the design phase and prioritize their needs to match their budget. Build/deploy. Building and deploying the systems will require hardware, software, and infrastructure. Infrastructure refers to space, heating and cooling, and power requirements for desktop network, server, and backup equipment. Depending on the designed approach, the system's components may include hardware for project operations, design, production, and contract administration, workstations or desktop computers, monitors, and peripherals, portable workstations or laptops with docking stations, mobile devices such as tablets and cell phones with software that integrates with project management, financial management, and construction management software systems, IT infrastructure, internet services/connectivity, including servers, storage, networking hardware, output devices, laser printers, inkjet printers, large format plotters and/or printers, 3D printers, scanners, 3D visualization hardware, VR/AR, software systems for the project operations, project management software for work, schedule, cost, quality, and risk management, CAD/BIM applications for designing construction drawings and models, construction contract administration software for conducting and reporting field observations and change management, word processing and database software for SaaS option, typically via web and mobile. Document management systems for distributing and archiving project documentation. Technology systems for the business operations. Accounting/finance, accounting software, financial reporting. Communication, phone, email, chat. Human resources management, HRM software. Employees and contractors' time and costs need to be tracked for accounting and financial reasons. Some features to consider: timesheets, employee information, hiring interview process, performance reviews, exit interview process. CRM, sales and contract administration. CRM software helps to manage the sales-related activities within the firm. Some functions to consider include the ability to centralize client contracts, track potential clients' leads, track potential projects and estimated revenue, generate reports on the sales pipeline based on estimated revenue from potential projects. Systems integration, project information rolling up into CRM, centralized authentication systems. Support and backup. The key reason for maintaining technology systems is to ensure business continuity in all situations, particularly when unexpected or crisis events demand immediate attention. Consider what would happen in an emergency such as a flood, fire, or break-in. Valuable information could be permanently lost. Prior to the widespread use of computers, financial and space resources were required for archiving paper drawings and documents. Although data and information are now created digitally, the need for business continuity has not changed. It has moved into the domain of technology systems rather than physical warehousing. A firm should develop a business continuity plan that addresses possible risk events, and that documents avoidance or mitigation strategies should risk events occur. As part of a business continuity plan, there should be preparations made to rapidly rebuild technology systems and restore data backups. Data backup and restoration. A data backup system will periodically make copies or snapshots and is meant for short-term availability if an issue occurs. For example, if the file share system hardware fails, then the most recent backup should recover enough data for staff to continue to work. Security/access controls. Access controls are an important aspect of information compartmentalization. To protect proprietary information, it is often segregated based on need. For example, managers or experienced staff would have access to past projects, while new staff would be limited to active projects to avoid accidental modifications to important documents. Legal and professional requirements. For legal and professional reasons, certain types of documents must be kept in case of a dispute or audit. This is often referred to as an archiving/retrieval system, which is different from a backup system. An archiving/retrieval system provides for the organization of information, searchability, and outputting data and information in a format appropriate for an intended use, such as an insurance claim or litigation. Maintaining productivity. Over time, computer system performance decreases with the detritus of web surfing, program installation and uninstallation, browser add-ins, inappropriate settings of antivirus software, deteriorating physical hard drives, and bloatware, software that is loaded with other software that robs performance. Maintenance is required to keep a computer clean, stable, and functioning properly. Okay, so that was chapter 3.7 from CHOP and Technology Systems. Thank you all for listening. Subscribe if you like this, and I'll see you next time.